For this example, we want to find a value for c so that the system of equations below has no solution. So we have two equations and we notice the first equation has a capital C. That's going to be some number we can put in there that would give the system no solution. Our easiest way to check if we have a solution or not is to compare our slopes and our y-intercepts. So let's rearrange the first equation and try to put it in slope-intercept form. So the first thing we can do is move that x term to the right side, and we'll have 6y equals 4x plus c. And we can also see that we'll need to divide by 6. I know we have a letter c in there, but we can just do that one as a fraction, and we can divide everything else to the best of our ability. So 4 over 6 will reduce to 2 over 3. I'll do that in the same step. And for c, because we can't really divide it by 6, we're just going to write it as c over 6. And that gives us our first equation. Let's see if we can get a nicer 6 in there. There we go. Our second equation has the same slope. So we have y equals 2 over 3 x plus 1. Now we kind of have two cases when we have the same slope. It's either possible that they could have a different y-intercept or the same y-intercept. If they have the same y-intercept, there will be infinite solutions. So let's just look at that case first, even though I know that's not what we're looking for now. To have infinite solutions, we would have the same slope. So c over 6. Sorry, I meant to say we would have the same y-intercept in addition to the same slope. We would have c over 6 equals 1. Now that's only going to be true when c is equal to 6. In all other cases, if we have the same slope, which we still do, but we have a different y-intercept, we would have no solution because the lines would be parallel and not touching. So c is any number aside from 6. We can test that by picking a value for c. Consider what would happen if c was 12. You would have 12 over 6, which is equal to 2. That would give you a different y-intercept. So it can be any number except for 6, because 6 is the case that gives us infinite solutions instead. Now let's take this last example as a chance to practice the skills we've gone over. So determine by looking at the equations whether each system has an infinite number of solutions or no solution. So you can do this one. Start with your slope. Check if they're different. If they are different, then we have intersecting lines. And one solution. In our second case, the slope is the same, but we have a different y-intercept. Those lines are parallel and have no solution. Our third case is if the slope is the same, but the y-intercept is also the same. That will give us coincident lines or the same line. So take a look at each of these examples and try for yourself. Can you rearrange into slope-intercept form? And pause the video and come back for the answer afterwards. Now let's take a look at a faster way of doing that. So if we take a look at our two equations on the left, I notice that first equation can actually be reduced by 2. We can divide each term by 2, and we'll get x plus 5y minus 8 equals 0. Our first equation and our second equation are exactly the same, and I can see that just by noticing that the first equation is the second equation multiplied by 2. So even without rearranging it, I can see that they're the same line and will have infinite solutions. For the example on the right, we can kind of analyze even without having to rearrange. Look at your x and your y terms. Being the same like that tells us we're going to have the same slope, but this constant number at the end, plus 4 and minus 6, tells us we'll have a different y-intercept and therefore no solution.